What if everything you thought you knew about our solar system was wrong? Picture the planets not neatly circling our sun on a flat tabletop, but scattered like marbles flung across a three-dimensional space. Imagine Jupiter, not as the gas giant we know, but as a blazing second sun, altering the fate of Earth and rewriting the story of life. What if the edge of our solar system isn't where you think it is, and our nearest neighbor in the cosmos is far more distant than we realize? In this journey, we'll uncover the hidden truths, shatter long-standing misconceptions, and explore the grandest structures that could ever exist around a star. Let's start with one of the most visually deceptive realities in astronomy, the orbital plane of the planets. When you look at diagrams of the solar system, it's always the same circles on a flat disk. Mercury, Venus, Earth, Mars, all the way to Neptune, they seem to orbit the sun on this perfect, invisible table. And that's not entirely wrong, but it's also not entirely right. All the major planets do orbit roughly in the same plane, known as the ecliptic, tilted only slightly from each other. But why is that? The answer traces back to the very birth of the solar system. Over 4.5 billion years ago, our sun and planets were born from a vast, rotating cloud of gas and dust called the solar nebula. As gravity pulled material inward, the nebula began to collapse and spin faster, flattening out into a disk. This flattening is the same principle seen in pizza dough or spinning ice skaters' angular momentum. Most of the material concentrated at the center, forming the sun, while the rest of the matter coalesced into planets, all orbiting in the same general plane where that original disk once was. So, while it may seem like an artistic convenience, this flattened structure is a natural consequence of physics, not coincidence. But here's where the misconception creeps in: this plane isn't some rigid, perfect layer in space. There's variation. Pluto, for instance, orbits at a tilt of about 17 degrees relative to the ecliptic. The asteroid belt, Kuiper belt, and Oort cloud extend in far more chaotic, three-dimensional configurations. And comets, those icy messengers from the solar system's edge, can swoop in at wild, high-inclination orbits that pay no heed to the neat order of planets. So while most planets lie close to a shared plane, the solar system itself is far messier and more complex than the textbook diagrams suggest. Now, let's shift our gaze to the most massive planet in our solar system, Jupiter. Weighing over 300 times more than Earth and more massive than all other planets combined, Jupiter is a behemoth. But here's a tantalizing question that often sparks curiosity. Could Jupiter have become a star? The short answer: almost, but not quite. Jupiter is made mostly of hydrogen and helium, just like our sun. In fact, it even emits more energy than it receives from the sun, thanks to leftover heat from its formation. But to ignite the thermonuclear fusion that powers a star, a celestial body needs a tremendous amount of mass. For hydrogen fusion to begin, an object needs to be at least 75 times the mass of Jupiter. Had Jupiter gathered just a little more matter in those early days, our solar system might have ended up as a binary star system, but it didn't. Instead, it became a failed star, or what astronomers call a sub-brown dwarf. Still, Jupiter's gravitational might is staggering. It shapes the orbits of other planets, deflects asteroids, and protects Earth in ways we often overlook. It may not have become a star, but in many ways, it acts like the solar system's guardian, its vacuum cleaner, and its second center of gravity. The idea of Jupiter as a star isn't just a scientific, what if it's a reminder of how thin the line can be between different kinds of celestial giants? But if you think our solar system is impressive now, imagine how much bigger it could have been. Let's talk about the largest possible planetary system that could exist. Could a star host not just 8 planets, but dozens or hundreds? Surprisingly, yes. There's no theoretical upper limit on the number of planets a star can have, only practical limits based on gravitational stability. In fact, astronomers have found stars with dozens of exoplanet or planet-sized objects orbiting them. Theoretically, if you had a star much more massive than the Sun, with a large enough protoplanetary disk, and enough time, you could build a planetary system with hundreds of worlds, from rocky Earth-sized planets to gas giants and icy dwarfs. Picture Saturn-like planets with moons that rival Mars, all orbiting a massive blue-white star. Some of those moons might even have rings of their own, or atmospheres thicker than Earth's. Such systems would dwarf ours in complexity and scale. But even in our own solar system, the reach is much farther than most people realize. Ask the average person where the solar system ends, and they might say Pluto or maybe the Kuiper Belt, but that's just the beginning. Beyond Neptune lies the Kuiper Belt, filled with icy objects like Eris and Haumea. Farther still is the scattered disk, and beyond that, the hypothetical Oort cloud, a spherical shell of icy debris stretching possibly a light year from the Sun. If the Sun were the size of a grapefruit, Earth would be a pinhead about 15 meters away, and the Oort cloud would be more than 2 kilometers distant. The solar system's true boundary isn't the orbit of a planet, but the edge of the Sun's gravitational influence, where the pull of our star is weaker than that of passing stars and the galactic tide. All of this brings us to a fundamental question. How big is our solar system, really? The answer depends on what you mean by solar system. If you mean the region dominated by the Sun's gravity, it extends far beyond Pluto, perhaps out to 100,000 astronomical units. That's over 100 billion kilometers. The Voyager spacecraft, which have been traveling for nearly 5 decades, are only now reaching the edge of the heliosphere, the bubble carved out by the solar wind. Beyond that lies interstellar space, a realm of cold, dark, and silence, where the Sun is just another star in the sky. But if you mean the region influenced by the Sun's radiation or magnetic field, or even just the place where its light is the brightest source, those boundaries are all different. Some scientists argue the solar system ends at the heliopause, others at the edge of the Oort cloud, and yet others say there is no clear boundary at all, just a gradient of influence that slowly fades into the galactic background. So, the solar system isn't just a tidy set of orbits or a handful of familiar planets. It's a sprawling, dynamic, ever-changing system with fuzzy boundaries and surprising realities. It's filled with worlds we've never visited, mysteries we've barely begun to understand, and structures that stretch our imagination to the limit. Jupiter could have been a sun. The planets lie on a disk forged by cosmic laws. Our closest star is so far that light takes years to reach it. And what we call our solar system may actually span light years of space and time. We live on a tiny rock, orbiting a modest star, in a galaxy filled with hundreds of billions of other stars, each potentially with planetary systems stranger and grander than ours. The more we learn, the more we realize that the solar system is not what we thought. It's bigger, older, and more mysterious than we ever imagined. And perhaps, just beyond the edge of what we can see, there are more secrets waiting to be discovered, secrets that will change how we understand our place in the cosmos forever.